Hi, welcome to Math 171 Pre-Calculus Algebra. My name is Jennifer Lewis. I'm going to be your instructor this semester. We're going to be doing a lot of video lectures as you're seeing now. This will give you lots of opportunity to practice in class and discuss problems with your classmates and with me. So we're going to start our discussion with rules for exponents. Okay, so we're going to start by talking about the rules for exponents. This is a concept that you did way back in pre-algebra. You build on it a little bit each year as you went throughout your various high school levels or your DMAs. Just very basic understanding. It just simply means that if you're raising something to a power, so for example, maybe you've got 2 to the third power. The 2 we call the base, and the 3 we call the exponent, and this is just simply telling us that we need to multiply the base by itself this many times. So this will become 2 times 2 times 2, or 3, or excuse me, 2 to the third power, multiply these together, and you would get 8. Okay? So we've got various rules that we can use whenever we're working with exponents. The first rule that we're going to talk about is what we call the product rule. If you've got a base raised to a power, and you're going to multiply this times the same base raised to a different power, the product rule tells us that we can keep the common base and add the exponents. Okay? Why does that work? Well, let's look at an example. What if I've got something like, let's say I've got x to the third power, and I want to multiply that by x to the fifth power. Okay? So x to the third means that I'm multiplying x by itself 3 times. So I can say that this is x times x times x. X to the fifth means that I'm multiplying x by itself 5 times. So I could call this x times x times x times x times x. All of these are being multiplied together. So how many times am I multiplying x by itself? Well, if you count them all up, you'll see that you're multiplying x by itself 8 times. So that means that you have x to the 8th power. Okay? So this allows us to do a shortcut. Anytime that I'm multiplying these like bases, and they have to be the same base, I can keep that common base and add the exponents. And that will make my life a lot easier for some of the problems that we're going to be looking at. So that was a product rule. All right. The next one is called quotient rule. All right. The quotient rule tells me that if I've got a base raised to a power, and now I'm dividing it by the same base raised to a different power, this rule tells me that I get to keep the common base and subtract my exponents. So a to the n minus n power. Okay, why does that work? Well, let's say maybe you've got x to the 4th power, and I want to divide it by x to the 2nd power. Okay, so pretend like I don't know my rule yet. If I list these out, that's x times itself 4 times. And then I want to divide that by x times itself 2 times. And I know when this is division, this bar means division, so if I divide a number into itself, that gives me a value of 1. So I can cross out this and get 1. I can cross out another pair of x's and get 1. And then I'm just left with x times x over, and I just have a 1 in the denominator. So x times x is x squared. And my shortcut, I get to just simply subtract the original 2 exponents. So doing x to the 4th minus 2 gives me x to the 2nd over here. Okay? Okay, so my next rule is going to be the power rule. This one tells me that if I'm raising a power to a power, I get to keep my base and multiply my exponents. Why do we multiply our exponents in this situation? Let's look at an example. Let's say I've got x to the 3rd, and I want to raise that to the 4th power. What does that really mean? Well, if I'm raising this base to the 4th power, then I'm going to multiply my base by itself 4 times. So I've got x cubed times x cubed times x cubed times x cubed. All right, each x cubed is telling me to multiply x by itself 3 times. So you've got x times x times x, and you do that 4 times. All right, if you multiply x that many times, how many times am I multiplying x by itself? I'm multiplying it by itself 12 times. So x to the 12th would be my answer. That is why we get to multiply the exponents if we're raising a power to a power. Okay? Now the next rule is not quite as easy to explain. It's not as straightforward as the ones that we've discussed so far. Okay? My next rule tells me how to handle something raised to the 0 power. So if I've got the rule says that a to the 0 power is equal to 1. This is not so much a rule as a definition. It's just this is the way it is, and we just have to accept that. It doesn't really make sense to raise something to the 0 power because you can't multiply it by itself 0 times. But what we can do is look at a pattern that develops. Let's just choose a random base. We'll choose something pretty simple. So let's say that we're working with 2 to the 3rd power, 2 to the 4th power, etc. And let's just look at a list. So let's do 2 to the 5th power. If I do 2 to the 5th power, if I multiply 2 by itself 5 times, that gives me, how much does that give me? It gives me 32. What if I do 2 to the 4th power? 2 to the 4th power, multiply 2 by itself 4 times, gives me, I'll give you a second to think, that gives me 16. What about 2 to the 3rd power? 2 to the 3rd power, 2 times 2 times 2 is 8. 2 to the 2nd power is 4. 2 to the 1st power is 2. All right. Well, the next one in chronological order would be 2 to the 0 power. If I look at the pattern of all the previous results that I got, how did I get from one step to the next each time? To get from 32 to 16, and then to get from 16 to 8, I'm basically dividing by 2. I'm dividing by my base. So if I divide this number by base 2, it gives me 1. So really, anytime you're raising something to the 0 power, that just means that you're dividing it by itself. So that's why it always comes out to equal 1. So that is the forgive me, I can't remember the formal name for this rule, but anything raised to the 0 power will always equal 1. All right, now my next rule tells me how to handle, and I probably should mention that I'm not going in the exact order that's in your notes. The notes are based on the textbook definitions, so the order is a little bit different from what I'm doing. But my next rule, I'm going to talk about how to handle a negative exponent. So if I've got a base raised to the negative power, let's say I've got a to the negative n power. Again, it does not make any, you can't really raise something to a negative power because you can't multiply it. No, let me rephrase that. You cannot multiply anything by itself a negative number of times. So our traditional definition of a negative exponent doesn't exactly fit the situation. All right, but again, look at the pattern that we saw over here. If we're working with base 2 like we saw earlier, each time I divided by 2. So I'm going to move my board for a moment and continue with this pattern that we saw. And you can't see that. So as we saw before, we had 2 to the 1st was equal to 2. 2 to the 0 power was equal to 1. If I continue with this pattern, if I do 2 to the negative 1st, I want to divide the previous result by 2. Well, 1 divided by 2 is going to give me 1/2. Or you can say that's 1 over 2 to the first power. All right? Okay? If I want to find 2 to the negative second, that means I need to divide my previous result by 2. I want to do 1/2 divide by 2. What does it mean to divide by 2? We know from basic arithmetic, if you're dividing fractions, that means you're going to multiply by the reciprocal of the second fraction. You're going to flip it. So if I did 1/2 divide by 2, 1/2 divide by 2 means 1/2 times, flip that, and you're doing 1/2 times 1/2. So it's going to become 1/4. Or, so you can say 2 to the negative second equals 1/4, which is also 1 over 2 to the positive second power. Now, I wouldn't expect you to write it that way necessarily, but you should understand that 1/4 is the same thing as 1 over 2 squared. And by writing it this way, we can see a new pattern starting to emerge, where we had 2 to the negative first power. That became 1 over 2 to the positive 1 power. 2 to the negative second became 1 over 2 to the positive second power. So what's happening with these negative exponents and these as we continue to go through this? The negative exponents are actually moving our base into the denominator of our fraction, and the sign of the exponent is changing when that happens. So you're going to have to remember and understand that the negative exponents are telling you to essentially create a reciprocal, which means either move it. If it's already in the top of the fraction, you're going to move it into the denominator. If it starts out in the denominator, you're going to move it into the numerator. When you move that base, that sign on the exponent will change. So if it started out as 2 to the negative second in the denominator, move it to the top, and it'll be 2 to the positive second in the numerator. We don't like negative exponents. We're leaving a negative exponent in a final answer is kind of like leaving a fraction that's not been simplified. We don't want to do that. So we're going to have to make sure that we're comfortable manipulating these negative exponents. So with that explanation, hopefully you understand why we can rewrite a base to a negative power as 1 over that base raised to the positive power. So that gives us another rule to work with. All right. The remaining rules are just extensions of the ones that we've done so far. There are 3 more that I'm going to talk about with you. Okay. The next one I believe they call a power of a product rule. So if you're multiplying 2 factors together and you're going to raise the whole thing to the same power, this rule simply states that you can raise each individual factor to that same power. So it should be easy. Maybe I shouldn't say easy, but this is something that you should be able to work through and figure out why it happens. Why does it happen? What if let's say you've got AB raised to the 3rd power, just for example, okay? Well, that's going to be AB times itself 3 times. I guess you could think this is like a proof that we're doing here to see why it works. So you're multiplying AB by itself 3 times. These are all being multiplied, and the commutative property of multiplication tells us that we can rearrange the order of these. So we can write this as A to the A times A times A times B times B times B, which is simply A to the 3rd times B to the 3rd. And that's what this property tells me that I can do. I can bring that exponent into each individual factor. So A times B in parentheses to the nth power becomes A to the n times B to the n power. So that's my rule, and that's why it works. All right, we have a similar rule for dealing with a fraction raised to a power. If I've got A over B raised to the n power, okay, very similar logic from the previous example, allows us to write this as A to the n over B to the n. All right, this one you may use, you may not use, it's okay, but it is there for you if you need it. And then finally, the last rule that I'm going to discuss is really not a rule itself. It's just a combination of other rules that we've talked about. If you've got a fraction being raised to a negative power, if I combine two of the previous rules, well, first of all, I know that the negative exponent tells me to create a reciprocal. So I could say it's 1 over this big fraction here. And so 1 divided by this fraction, when I divide the fraction out, it just turns into b over a. It just takes the reciprocal of it. So it will become b over a. And then the sign of this exponent changes. So b over a raised to the n power is the last rule that I'm going to discuss. All right, and that's something that I might ask you to tell me why that works at some point. So that's where we are on those are the rules for exponents. And now we can start looking at examples of how these work. Okay, so our first example for this section, we're being asked to simplify without using a calculator. In part A, we're doing 4 times 2 to the negative third power. The first thing I notice is my negative exponent. The negative exponent rule tells me that I can rewrite 2 to the negative third as 1 over 2 to the positive third power. So we've got 4 times 1 over 2 to the third. I can then, rules for exponents tell me to go ahead and handle any exponents first. So 2 to the third gives me 8. 4 times 1/8. And then multiplying, when I multiply fractions, I multiply straight across the top, straight across the bottom. If you want to, you can go ahead and simplify at this point. That's fine too. If I multiply these together, I've got 4 over 8. And then I know that 4 over 8 can be simplified as 1/2. So my answer is 1/2. For part B, we have 6 to the negative second over 2 to the negative third. We know that if we're working with negative exponents that we want to move them. So let's go ahead and rearrange these so that we can have positive exponents. We'll move this into the top as 2 to the third power. And then this will go into the bottom as 6 to the positive second. All right. I cannot apply a rule for exponents at this point because notice I have different bases. So I need to just go ahead and expand these out. 2 to the third is 8. 6 to the second is 36. And then this can be simplified by a factor of 4. So that becomes 2 over 9. I keep running out of space at the very end. So my answer is 2/9 for part B.